This video will be on Chapter 7. In Section 7.1, 7.2, 7.3, these three sections will kind of be within this recording. Okay, so Section 7.1, Linear and Nonlinear Systems of Equations. Success is not final. Failure is not fatal. It is the courage to continue that counts. Unknown. So first, let's look at some definitions. All equations in the form ax plus by is equal to c are straight lines when graphed. Two such equations are called system of linear equations. A solution to the system in two variables is an ordered pair that satisfies both equations in the system. A system of linear equations can have exactly one, two, or infinite many solutions, or no solution. A linear system that has at least one solution is called consistent, and one that has no solution is called inconsistent. So basically in the definitions, if you have two equations, then we call this a system. And our goal is to figure out, in example 1, is if this ordered pair is a solution to this system. In order for us to check, we can substitute the value of x and y into the equation. So I'm going to write the first equation, 2x minus 3y equals -4. Substitute my x, which is 1, and my y, which is 2. And so we get 2 minus 6 is -4 and -4. So this ordered pair is a solution to the first equation. In order for it to be a solution for the entire system, it also has to work for the second equation. So let's check the second equation. So I substitute 1 for x and 2 for y. And so we also get that that's a solution for the second equation. Since it works for both, then we say that the ordered pair one, 2 is a solution to the system. So let's try example 1b. So first we need to check the first equation. So I'm going to substitute 7 for x and 6 for y. 14 minus 18 equals -4. -4 is equal to -4, so that works for that solution or that equation. Let's test the second equation. So replace x with 7 and y with 6. So we get 20 is equal to 4, and that is not true. Okay. So this ordered pair only works for the first equation, but not the second. So we say that this ordered pair is not a solution to the system. Okay. So a system can be a system with only linear equations, or it could also have nonlinear equations. And there's three ways that we're going to find these solutions. One way is to use substitution, elimination, addition, or to graph. And the solution when we have the graphs is where the graphs intersect each other. So for example, find the solution to each system below if it exists. So here I have one equation, and then I have my second equation. So our solution is going to be where the two equations intersect. So this is going to be our solution here. This is called a linear system since it's only made up of linear equations. And the solution we write as the ordered pair of 2, 0. Okay, on the second system, this is called a nonlinear because it includes equation that is not a line. So here we have a parabola and a line. The solution is where the graphs intersect. So notice they intersect at this point, 0, -1, but they also intersect at this point, 2 and 1. So in this example, the system has two solutions. And then the third one is still nonlinear since we have a parabola involved. And the solution, notice that the line and the parabola never intersect. So we say there's no solution. So let's go on to the next example where we're going to look at two methods, substitution and elimination. And so I'm going to work the same example using both methods so that we can compare them. So here we have our system. I'm going to go ahead and write the equation in here. So we have our first equation, x plus y equals 4, and our second equation, x minus y equals 2. So the first step is going to be to solve one of the equations for one of the variables. And so I can pick the first equation, and I'm going to go ahead and solve for x. So I'm going to solve for x by subtracting y on both sides, and so I get 4 minus y. So I'll be using this equation here. The second step is to substitute your new equation. It's really not new, it's just rewritten differently. In step 1 into the other equation not used. And then we're going to solve for the variable. Okay, so for example, here we didn't use equation 2, so I'm going to write it down. And then I know from step 1 that x is equal to 4y minus 1, so we're going to replace this x by that information. So we're going to have 4 minus y equals 2, and then we're going to solve for y. So 4 minus 2y is equal to 2. Subtract 4 on both sides. So we get negative 2y is equal to negative 2. So y is equal to 1. Your solution should always be an ordered pair. So step 3 is going to be to back substitute our answer in step 2 into one of the equations from the original systems. Or it could also be this equation that we have that we rewrote. So I'm going to go ahead and use equation 1. So here I have x. I don't know what x is. But now I know what y is. Y is equal to 1. So I can replace y with 1 and solve for x. So my solution is x is 3 and y is 1. So this is our answer here. Okay, so that is how the substitution method works. For the elimination method, let me write our two equations. So for the elimination, your equation should be written in this form, where you have your x and y on one side and your constant on the right side, or vice versa. In order for the elimination to work, you're going to pick a variable. You want to make sure they have opposite signs, like the y's here. This is positive, this is negative. And the coefficients in front of the variable have to be the same. So in this case, you have a +1 and a -1. If that's the case, then we can just add the two equations. So x plus x is 2x, y plus negative y is 0, and 4 plus 2 is 6. So divide by 2, so x is 3. Once you have an answer for one of the variables, then we back substitute as we did in the substitution method. And you can pick any of the equations. So x here we found out is 3. Subtract 3 on both sides, so y is going to be equal to 1. So our solution is x is 3 and y is 1. So notice we get the same solution as this method. And so it's going to be up to you to decide which method you prefer. I myself usually use depending on how the system is written. So in the next example, you can see what I mean by that. So we have solved the system using any method, and I'm going to go ahead and use both methods just so that we can get familiar with both first, and then later I'll start using just one or the other. So for the first one, I'm going to use substitution. So I'm going to write x minus y is equal to 4. And so I'm going to choose this equation and I'm going to solve for x. So I'm going to solve for x. So x will be equal to 4 minus y. Okay. So now the second equation is 5x minus 3y equals 6. And I already know that x is equal to 4 minus y. So I can substitute that in for x. So I get 5 times 4 is 20. 5 times y is negative 5y. Minus 3y equals 6. 5y and 3y is 8y equals 6. Subtract the 20. So we get 8y. Negative 8y is equal to negative. So here, let's just go back really quick. Notice here I have x minus y equals 4. So I need to add y on both sides. So this is going to be 4 plus y. And so when I substitute it in here, I'm going to get 5 times 4 is 20. 5 times y is positive 5y. And so 5y minus 3y would give me a negative 2y. So I'm going to have negative 2y is equal to negative 14 divided by negative 2. So y is equal to positive negative 7. Okay, so let me just repeat that. We solve for y. I add y on both sides, substitute it for x. So we get 5 times 4 is 20. 5 times y is 5y. Minus 3y equals 6. So 20 plus 2y. 5 minus 3 is 2y. Subtract the 20, so we get negative 14. Divide by 2 on both sides, so we get y equals 7. So now we back substitute. And so I can pick the first equation. X is, we don't know what the value of x is. Y is negative 7. So x is going to be equal to negative 3. So my solution is x is negative 3 and y is negative 7. Okay, so if we use the elimination addition method, then it would look something like this. So first you pick a variable, so we can choose x or we can choose y. So I'm going to go ahead and choose x. So if I wanted to choose x, then here we would have, let me write the equation. I need to multiply this equation by 5. So here I get 5x. Let's multiply it by -5. So we get -5x plus 5y is equal to -20. Then the second one would be 5x minus 3y is equal to 6. Notice that now I have the same number with different signs, so same coefficient, opposite signs. So if I add these, I get 2y is equal to -14. Divide by 2, so y is equal to -7. And so then we would back substitute as we did with the substitution method. So our solution would be -3 and -7. Okay, so let's try example 5. You can use any method. So when the equations are set up like this, I like to use the elimination method. So here, notice that I have a 5 and a -10. So if I want to eliminate the x's, I would have to make this 5x become a positive 10x. So I'm going to do that first. So in order to do that, I would have to multiply this entire equation by 2. So I get 10x minus 4y is equal to 8. So now I can use that equation and the second equation. And so if I add these, this is 0, this is 0, and 15. So 0 is equal to 15. We know that's not true. Okay. So what we say is this is not a true statement. So what that means is that there's no solution. So if we were to graph these lines, basically there would be two lines that are parallel and it will never intersect. So they will either be going like this or they will be going the opposite direction, but they'll never intersect. Okay, let's try example 6. Notice here the way the equations are set up. One of the equations is already set up for x. Whenever that happens, then I like to use the substitution method. So here, we know that x is equal to 4y minus 8. So we can substitute that in for x. So 5 times 4 is 20y minus 40 minus 20y equals -40. 20y minus 20y is 0. So we get -40 is equal to -40. So what that means is this is a true statement. So what this means is that there is infinite many solutions. If we were to graph the equations, what would happen is you would have your first line, and then on top of it, you would have the second line. Okay, so let me illustrate that with the decimals app. So we can see the graph. So here we have x is equal to 4y minus 8. And then I'm going to put the second equation, 5x minus 20y equals -40. So notice it lands on top of the other equation. So there's the first one in red, and then the second one is blue. It falls on top of it. So what that means is that all of these points are going to be common to both lines. And so that's why we say it's infinite many solutions. The way we write our solution is we say that for any x and y, and then we pick an equation. You can pick the first one or the second one. And so this represents that there's many solutions. Okay, so let's look at example 7. A chemist needs to mix an 18% acid solution with a 45% acid solution to obtain 12 liters of a 36 acid solution. How many liters of each of the acid solutions must be used? So basically what's happening here is we have bottle 1. So here's my bottle, and that's 18%. And then we have bottle 2, and that's 45%. And then we need a bottle that is going to have 36%. Okay, so what we can do here is we have this bottle plus this bottle should give us 12 liters of the first bottle of this bottle that we need. So we need 12 liters of that bottle. What we know is that the first bottle is 18% acid solution, and the second one is 45% acid solution, and the new one that we're interested in is 36% acid solution. So basically we have two equations, x plus y equals 12 and 0.18x plus 0.45y. 12 times 0.36 is 4.32. And so we can solve using the systems. So I'm going to get rid of the x's. And to do that, I'm going to multiply this equation by negative 0.18. So this would become negative 0.18x minus 0.18y is equal to 0.18 times 12. So let's see what that is. Let me turn this on. 0.18 times 12, 2.16. So that would be negative 2.16. And then the second equation was 0.18x plus 0.45y equals 4.32. If we add these, negative 0.18 plus 0.45y is 0.27y, and negative 2.16 plus 4.32 is going to be positive 2.16. Divide by 0.27, and y is going to be at 8. Now that we know that y is 8, then we can figure out x. So I'm going to use back substitute, and I'll use the first equation. So we have x plus 8 liters of the second bottle is equal to 12. Subtract the 8. So x is 4. Since this is a word problem, it's nice to write a sentence here. So we need 4 liters of the 18% acid solution, and we need 8 liters of the 45% to make 12 liters of 36% acid solution. Okay. So let's look at example 8.